Hi, this is about finding the nth term of a sequence. Our first method that we've learned will probably be based on relying on the previous term in order to calculate the next term. But that's a bit of a disadvantage because it might be a little awkward if you try to find the 999th term and you're only given the first 5 terms. So a more efficient rule is to have terms related to their position in the sequence. And that's how we're going to tackle the next 3 problems. So this is our sequence. We'll just create a little table. So we'll have their position 1, 2, 3, 4, and 5. And we have 3, 5, 7, 9, 11. We need to find a relationship between the position of a term and the term itself. And if we look at a pattern here, we can see 1 times 2 add 1 is equal to 3, and 2 times 2 add 1 is equal to 5, and so on. So this will continue, and we can see a pattern emerging. Now what are we seeing? We're seeing that we're multiplying the position by 2 in each case. In this case here, again, we multiply the position by 2, and that's consistent. We're always doubling the position and then adding 1. Now, n we have as representing the positions. So we have a formula for the nth term would be 2, we're at 2 times the position, 2 times n, and we add 1 to that. So the nth term, let's just rewrite that. Nth term is 2n add 1. And now if you wanted to work out the 99th term, we'll just multiply 2 by 99 and add 1 to find out what that number would be in the sequence, or what that term would be in the sequence at position 99. Here's another sequence. Looks less familiar. And again, we'll create a table. So position 1, 2, 3, 4, 5. And this is designated by n. The positions are n. Now, let's look for patterns. We have 1 times 1, add 1 will give us our first term of 2. We have 2 times 2, add 1 will give us second term, 2 times 3, add 1 will give us, oh sorry, I made a mistake there, 3 times 3 times 3, add 1 equals to 10, 4 times 4, add 1 is equal to 17, and so on. As we can see, the position of the term is multiplied by itself. So we're squaring the position of the term and then adding 1 to it. We know the position is represented by the letter N. So our nth term is n squared. We squared the position of the term and we add 1 to it. We can check. For 5 we have 5 squared is 25, add 1 gives us 26, so that works. Here's our next sequence. It looks rather strange, but again we'll create a table. Our positions are n. Now, when you look across at the terms, you can see a difference of 8. So from -4 to 4 is 8, from 4 to 12 is 8, and so on. So with that, it must have an influence on your nth term. So the first guess will be to multiply 8 by the first term, and that will give us 8. But how would we get to -4? Well, if we take away 12 from that, it will give us 8 minus 12, which is -4. So that's our first term. We go again with 8, multiply by the second, or position 2, take away 12, and that gives us 4. 8 times position 3, take away 12, it gives us 12. And this looks like the pattern that we've identified. So we've multiplied 8 by the position, so the nth term here is 8 times the position, which is n, and then we subtracted 12, or added -12 to it. Let's check it for the last term. 8 times 5, which is 40, take away 12, gives us 28. So that's a check that this nth term, 8n minus 12, is correct for this sequence of numbers. And that's it. My name is Alistair. Thanks for watching this video. Any comments or questions are welcome. Please like, and also follow for more videos like this. Thank you. Bye for now.